very important topic, Galilean transformation. This Galilean transformation is actually the set of equations which correlate two frames of reference. Those are the inertial frames of reference. One is stationary and other is moving with constant velocity. Here, consider this is S frame which has xy coordinates. Z is also not drawn here, and there is a S dash frame which has coordinate x dash, this in this direction, and the y dash parallel to the y, and x and x dash are parallel. Okay, and consider there is a point P which is at distance x from the S frame, and there is a one person which is standing at location P1 which is in S frame, and there is another person which will be moving with S dash frame. Okay, so this S dash will be moving ahead in the positive x direction, and P2 also moving into the x direction. T equal to 0 time, this P2 will start moving in x direction. Okay, P1 is the distance between this point P and this S frame will continuously goes on decreasing. Okay, but the distance of this point P from S will be the fixed, that is xo. Okay, now then Galilean transformation links these two frames of reference as, if you take coordinates, x coordinates for S frame, so that will be x only, the distance of point P from this frame. Now for this moving frame, the distance will be the function of this x minus u into t, because u into t is actually the distance traveled at this moment by this S1 frame, S prime frame, or person 2, where u is the velocity, that is the constant velocity. This person 2 is moving in positive x direction. So u into t, that velocity into time, gives the displacement or distance covered by this frame or person 2. Okay, so here x dash, that will be the distance of point P from P2, is equals to x minus ut. Okay, so here we saw that x dash will be equals to x minus ut, and y dash and y will be the parallel, therefore no change in this. Y dash equal to y and z dash equals to z, and t dash equals to t. Okay, this prime indicates here a moving frame, the coordinates of the moving frame, and time will be the same here, therefore t dash is equals to t. And now move on to here. So this equation number 1 can be remembered, known as the Galilean transformation. These two S and S dash frames are linked with this. Okay, suppose point P starts moving with speed v. Here the speed of S prime was u. Now consider this point P will start moving in this x direction with velocity v, that is mentioned here. The P1 calls changing distance to the point x, and that will be v equal to dx by dt. The velocity observed by P1 for this point P will be dx by dt, therefore it is mentioned here, v equal to dx by dt. And give equation number 2. Now differentiating equation number 1, derivative x dash, okay, dx minus u dt. Okay, u को हमने जैसे कि वैसे ही रखा है, लेकिन t को dt लिखा है. Okay, u को क्यों रखा है वैसे ही? Because this is a velocity which is a constant. Okay, and now divided this equation by dt, we will get dx by dt. Okay, as we know that t is equal to t dash is equals to t, so their derivative dt dash will be equal to dt. So we can change this dx dash by dt to dx dash by dt dash, and right hand side dx by dt minus u into dt by dt, dt cancel हो जाएगा, dx by dt minus u बचेगा. Okay, so here dx dash by dt dash will be the velocity v prime equal to dx by dt, that is v minus u. So what are this equation? This equation gives us what is the velocity observed of point P in P2 and P1, or by P1 and P2. So v dash will be the velocity of P in S dash frame. यानी ये जो पॉइंट अब राइट साइड में मूव करने लगा है, इसकी क्या वेलोसिटी रहेंगी एस डैश फ्रेम में, या फिर आप कह सकते हैं कि ये P2 इसकी वेलोसिटी कितनी ऑब्ज़र्व करेगा, तो वो ये ऑब्ज़र्व करेगा v प्राइम। और ये जो v है, ये तो वेलोसिटी तो हमने पहले ही लिखा है कि dx/dt है और पॉइंट आगे को जा रहा है, ठीक है। सो दिस वेलोसिटी ऑफ मूविंग पॉइंट P इन S फ्रेम और विथ रिस्पेक्ट टू S फ्रेम जिसे कह सकते हैं हम v माइनस u वेलोसिटी ऑफ P2 इज़ इन S डैश फ्रेम। यानी ये जो P2 है जो u वेलोसिटी से पहले से चल रहा है वो वेलोसिटी है, और v जो है ये वाला v जो वेलोसिटी है, वेलोसिटी मूविंग पॉइंट P इन S फ्रेम, ठीक है। तो ये दिस इज़ वेरी इंपॉर्टेंट इक्वेशन। यहाँ रिलेटिव मोशन को किस तरह से हम इस इक्वेशन से रिलेट कर सकें वो हमको यहाँ समझ में आता है। v प्राइम इक्वल टू v माइनस u, ठीक है। एक्सेलरेशन इन बोथ S एंड S डैश फ्रेम कैन ऑल्सो बी रिटर्न एज dv डैश बाई dt डैश, यानी यही इक्वेशन को आपको डिफ्रेंशिएट करना है। डिफ्रेंशिएटिंग इक्वेशन नंबर 3 वी विल गेट dv डैश बाई dt इक्वल टू dv बाई dt माइनस du बाई dt, but this du by dt will be 0 as this velocity is constant. The derivative of the constant is 0. Therefore, we will get, after differentiating this equation number 3, dv dash by dt dash is equal to dv by dt. और अगर हम इसे प्राइम फ्रेम में ऑब्जर्व्ड एक्सेलरेशन कहें तो हम उसे इंडिकेट करेंगे a डैश से, और dv by dt इसे हम a से इंडिकेट करेंगे, ओके। तो हम ये पाएंगे कि अनप्राइम्ड फ्रेम में एक्सेलरेशन जो ऑब्जर्व की गई है वही एक्सेलरेशन dv डैश बाय dt इक्वल होंगी, ओके, प्राइम फ्रेम में, जो कि हम सेम पाएंगे, ठीक है।